Okay, parasitic draw. We talked about batteries and realized they have a limited storage ability. I mean, they store chemical energy pretty easily, then they release it fairly well. Uh, but realize that even when you turn the key off, the car doesn't entirely turn off. There are certain draws that are there all the time, such as the clock and the keep alive memories for all the computers in the cars. And quite honestly, there's a lot of computers in cars now. I mean, power seats or power windows or climate control or radio or nav. All these things have a certain amount of keep alive memory that remains on all the time to keep the memories. Now, they try, the engineers, the automotive engineers, try real hard to make sure that, if the car is left off or left idle for a long period of time, it's not going to kill the battery to the point where you need to jump, stir or click. Nothing, nothing. Uh, Typically, they shoot for, a couple of weeks of downtime. There are many manufacturers that have special fuses, and if you look in your owner's manual, you'll find it. If you have one, they're called IOD fuses. That's ignition off draw. And if you're going to store the car for a longer period of time, you pull that fuse and it shuts everything down. Now you'll lose a bunch of memories doing that, and we talked about that when we were, cleaning the battery. How to keep those memories alive. So that's only used like if you're gonna like store the car for a long period of time. 6 months, a year, or something. So everything's all fine and well and good until that goes astray and something stays on when it's not supposed to. So how would you find that? I mean, what would you look for? Well, first thing you need to do is decide whether or not there's actually a draw that's drawing too much. Now, I have my car back in here, uh, and I've hooked up a pretty fancy piece of equipment. There it is. That's a little better. And you can see this thing works on a current clamp. I'll show you that in a second. And it's just clamped around the positive leads coming out of the battery. And I am showing about zero point 0.2 of an amp. The way this thing reads, we got to move the decimal place over one. It's a current clamp. And anyway, so I've got about 200 milliamps, okay, 190 milliamps. As long as I'm down in that range, I'm fine. What I'd like to see is, zero point 0 something, and then I know it's good. Now, zero point 0.2 isn't terrible. I start to get up above that. This is an old truck. That becomes a problem. I mean, quite honestly, I can't leave this truck parked for more than 2 weeks without having to jump it, you know? Uh, so anyways, here's how it's hooked up. Now, I've just got this cool guy current clamp clamped around the positive cable, and it inductively picks it up. Are there other ways to do that? Well, yeah, there is. Now, what I can do is I can disconnect my negative cable, which I will do, and I can insert oopsie. Insert my meter in series between the negative cable and the negative battery post. I got to switch this. Flip this over to read amps, and I'm going to range it over so that it reads big amps. So there it is. Now, it's a little bit higher because I just woke up all the computers. Give it a sec, it'll drop back down. If I didn't blow the fuse. No, I didn't. Give it a sec. And I'm about, 260 milliamps, which is higher than I'd like to see it. And if I give this thing a little time, it'll go back to sleep. I can cut this back to sleep time dramatically by, putting in my little keep alive battery thing. That would be this guy. But they did not do that. And you can see it's dropping back down again as the computers are going back to sleep. Some cars take an awfully long time to go back to sleep. Some of the newer cars won't go back to sleep at all if the key is nearby. The new ones, the push button starts where all you got to do is walk up and the car knows you're there. It's reading the key. So if you're working on one of those, I usually stick the key in some tin foil or throw it in my toolbox. Usually it's about 6-8 feet, but some of those things are 20 feet out. We okay? So, all right. So this is how you trip the door so that the truck will go to sleep. And all I'm going to do is just take a Allen key, a big one, and I'm going to trip this latch right here. Now, just remember, don't slam the door while you have the latch tripped. And I'm going to grab my meter. Light this up. And I'm just going to do a voltage drop across these fuses. I set my meter for millivolts, and as you can see, it's bouncing around because I don't have the meters, the test leads connected to anything. They're just sitting out here in the open. But as soon as I touch them together, they go to 0. So bouncing around means the leads aren't touching each other. So I'm going to go to the fuse tabs. I don't know if you can see it. And I'm going to go to each of the fuses that are in here inside this inside fuse box. And I'm going to go between these little tabs. So I check this one, make sure I get a good connection, and I got 0. That means no current draw through that fuse. Now I've gone through every single one of these, and this one is the one that has a draw. And it's fuse 26. Hang on. And as you can see, it's not bouncing around. I've got a good connection. So I've got, oopsie. Hang on. Slipped off. Try again. There it is. I've got a reading. Oopsie. Keeps that sliding around. Come on. There it is. Oops. Moved again. 1.4 millivolts. That's my voltage drop across this fuse. That tells me that this fuse has some current flowing through it. Now I could go through the rest of these, but all the rest of these are dead. It's just this one, and I can prove it's that one by pulling it out. And I look at my meter, and I've got next to nothing. So it is that fuse that's drawing the 200 milliamps. So, oopsie. So what am I going to do with this? Well, I'm going to go and I'm going to look on Mitchell and find out what that fuse is for to tell me if this is normal or not. So I'm going to switch screens here. And I'm going to bring up the Mitchell. If you look, that's fuse 26, and here it is. And it goes to this battery saver relay. And this is connected to all the dome lights. Now, it's kept on. Here's the coil. This just runs to a hot all the time fuse. So I got positive on this side of the coil. I need negative on this side of the coil. That's this purple-orange line, and that is driven by the GEM module, the generic electronic module. They call it a GEM on Fords. It's a computer. So this guy is keeping that relay on. Now, that relay also powers all these lights. You know, the interior lamp and the outside cargo light on the back in the bed. So these lights are not on, so I know it's not the light bulbs that are drawing it, so the only thing that's left is this relay. So what keeps the relay on? Well, relay is turned on and off by the GEM, but the GEM is watching these two ground side switches, turn it on and off to tell when the doors are open. And I tripped the one in the driver's door. So it thinks the doors are closed. Now, it's going to take 20 minutes before the GEM goes, okay, I don't think he's coming back. Turn off the battery saver module. And that's in case you leave your dome lights on. So you accidentally leave your dome lights on. The truck is smart enough to turn the darn things off after a while so that you don't get the stirrer click or nothing in the morning. Get it? Get it? It's pretty simple. Now, if it was something else, I would have to dig into that circuit, and what I would do is figure out exactly what's on that circuit. You're looking at the power distribution, and then go look directly at whatever that is. And if there's multiple things, well, then I got to go to every single one of them that is powered by that fuse to make certain, figure out which one is drawing the current. That's one of the nice things about that current clamp that I'm using is, you know, let's say it's the PCM is on that fuse, and so is the BCM, and so is climate control. I can just go to each one of those, clamp around the power wire, and see which one is staying on. And then I got to figure out why it's staying on. And usually it's because something is amiss somewhere else. Rarely is it a bad computer. All right? So that's the kind of, in a nutshell, parasitic draw. I'm going to show you another thing here in a minute, but that's about it. Thanks. Hi, how you doing? All right, so I've left my truck sit overnight, and honestly, let me show you what I got. I've got next to nothing. 0.02 of an amp, which is fine. I don't have a problem with that. It took a while for it to time out. So this is normal. This is fine for this truck. This will last weeks this way. Parasitic truck.